Hey guys, and welcome to Behavior. As you might have guessed, my topic is on bees. So to start off with, bees can occur on every single continent except Antarctica. Basically, wherever there's an insect-pollinated flowering plant, whether it be like a city or a meadow or a forest, there are bees. First, we have the queen. She is there to give birth. She is there to keep the hive going. She is the head of the hive. And then there are the worker bees, which are the infertile women. They go out, pollinate, bring stuff back. And then there's the men, who are simply there to be there for the queen. Now let's get into Umwelt. Let's talk about the visual perception of the bee. Bees have a very wide field of vision, which is about 280 degrees, and each compound eye has about 6,300 cone-shaped facets or eyes. And they use these to navigate and to locate flowers from afar. Bees also have an amazing olfactory sense. They have about 5,000 to 6,000 olfactory detectors on each antenna, and they're used to detect chemical signals from the surroundings, which help them find food and find their way back to the hive. One taxis I discovered that bees have is olfactory tropotaxis. This means that they're simultaneously getting information from each antennae and using that to orient themselves. Now let's say I drop this little guy right off the Empire State Building. What would happen? So if it had its wings, it would just simply fly away. But let's say we take those away, and now the bee is just free falling from the Empire State Building. The bee is so small that falling off the Empire State Building wouldn't really have an extensive effect on it. It would just kind of get up and walk away. So my scientific question is, why do bees return to the hive at night? I hypothesize that they use all their energy in the day that they need to use that nighttime to sleep. This would, I believe, be considered as a causal Tinbergen's question. Okay, so here's the ethogram I made, and here is the video that we are going to watch, but let's push that to the side for right now. Let's go into some specifics about this ethogram. CLU means clustering, SL means sleeping, CLE means cleaning, GU is guarding, and N is none. The type of sampling I used was a scan sampling because I'm trying to observe a state that occurs with a group of bees. And it's very hard to tell each individual bee apart because they're almost always really close together and they move really fast. Now let's bring this back, and we will watch a piece, but not all of it because we are on a time crunch. This is an example of the clustering behavior I was talking about. After some more research, I found that a really common reason that bees return to the hive is so that they can cluster together and vibrate really fast to keep the temperature of the hive level when it gets cold at nighttime. To enhance the quality of the study that I just presented, I believe that we could repeat the sampling to see if we can find any more data that could possibly be interesting. We could also set up an experiment where we expose the bees to different temperatures to see if they react differently to prove the temperature theory that I just put forward. We could also try this with different species of bees.